We are starting the notes 521, and we're introducing ourselves to logarithms as the inverse of exponential functions. So first off, we're going to graph some parent functions and determine their inverses. So we're starting with y equals x squared. That is the parabola, right? The parent quadratic function. What are some key points? Tell me in class. What are some key points? Where do I start? 0, 0 is one key point. 1, 1. 2, 4. Okay. So 0, 0, 1, 1, 2, 4. You need to have those memorized. And then on the other side, negative 1, 1. Okay. We have a question. In the Google Meet, can you guys see okay? Can you guys see my screen? Can you confirm yes or no in the chat if you can see my paper?
We can see it.
I can't hear you. You're going to have to write it in the chat. Yes? Okay. Thank you. For some reason, I couldn't hear you. Okay, so yeah, so negative 1, 1 and negative 2, 4. Okay. So here we go. Draw our parabola, and we know that it keeps going in both directions. Now, to determine the inverse of this parabola, we're going to do it two ways. We're going to start out with the equation y equals x squared. And to determine the inverse, remember that we have to figure out what happened to the x and then apply it backwards. Another way of doing that is flip the x's and the y's. I know we didn't talk about this method too much, but the algebraic way of finding the inverse is to switch the x and the y. So let's switch the x and the y. Instead of y, I'm going to put x. And instead of x, I'm going to put y. Okay. So this is the inverse because I flipped the x's and the y's. And if I want to get the y by itself, what do I have to do to both sides? Take the square root of both sides. Okay. Now, if we take the square root of both sides, do we need a plus or minus? Yes. Okay. If we take the square root of both sides, we need plus or minus. So plus or minus square root of x equals y. And I'm a little OCD, so I want to put the y on the left side. So I'm going to do y equals plus or minus square root of x. Okay. This is the inverse. Okay. So the inverse of x squared is plus or minus square root of x. And we already said that, right? Because it has to be a sideways parabola. So the inverse square root of x, when we graph it, 0, 0, 1, 1, 4, 2. Okay. And then the negative square root of x is down here. 0, 0, 1, negative 1, 4, negative 2. Did I do it right? Are these inverses of each other? Do they reflect on the line y equal x? They should. Okay. All right. So they reflect on the line y equals x. That's how you can check that you did it right. Right here. All right, so we're just reviewing, right? We're reviewing how to graph a parent function. We're reviewing how to find an inverse algebraically by switching the x and the y. And then we're graphing the inverse, making sure that it reflects on the line y equals x. If I flip the parabola on the green line, it's going to land on the red parabola. Any questions so far? Okay. Moving on to number 2, y equals x to the third. So if I start with y equals x to the third, and I want to find the inverse, what did I do on the other problem to find the inverse? Switch the x and the y. So tell me what to write. Instead of y, I put x equals y to the third power. Okay, y to the third power. Can you guys see the screen okay, or should we turn off a light? Probably turn off the light, right? Just to make it a little better. Is that better? Yeah? Okay. All right. Cool. So now that we wrote the inverse, we have to get the y by itself. So how do I get rid of the third power? Cube root of both sides, okay? So I'm going to do it like this. I'm going to take the cube root of this and the cube root of that. Okay? When I do that, I get the cube root of x equals, what happens to the cube root and the cube exponent? They cancel out. Just like the square root and the squared exponent cancel out, the cube root and the cube exponent cancel out. And if I want to put the y in front, my final equation for the inverse is going to be y equals the cube root of x. Now, challenge question. Do we need a plus or minus? Here we put a plus or minus because we know that when you square something, when you square a negative, when you square a positive, you get the same answer. Do we need to do a plus or minus on the cube? No, because a cube root is always going to give you either a positive or a negative, but not both. Okay? So the only time you need plus or minus is when you have a even root, not with an odd root. So this is enough. So this is the inverse. And it should make sense, right? The inverse of cube is cube root. The inverse of quadratic is square root. So let's go ahead and graph both of them. Let's graph cube root. What are some key points on the parent function x to the third power? Where do I start at 0, 0, and then -1. I'm going to zoom in a little bit so that we can see better. Okay. -1, -1, and then 1, 1. So that's correct, but so far it looks like a straight line, doesn't it? Is it going to be a straight line? No. What are the other key points? 2, 8. So it's important that we put enough points so that we know what the shape is. And then -2, -8. So here is our snake looking graph. Our snake. Okay. All right. But now we have to graph the inverse. Ooh. Do you guys know what the cube root of x looks like? Have we graphed that one before? I don't remember. If we didn't graph it before, but we have the graph of the parent, don't we just have to flip the x and the y coordinates? So if this parent graph has 0, 0, and we flip 0, 0, we're going to end up at 0, 0. If we flip 1, 1, we're going to end up at 1, 1. If we flip 2, 8, we're going to end up at 8, 2, right? 2, 8, 8, 2, if we flip the x and the y. And if we flip -2, -8, we're going to end up at -8, -2. So our cube root graph looks like this. Does it reflect on the line y equals x? Yes or no? Yes. Very good. This is the line y equals x, y equals x. Okay. All right. All right. Let's graph y equals x. Oh, that's easy, right? This is a line. Let me zoom out a little bit. Okay. This one is a line with a slope of 1 and a y-intercept of 0. So we start at 0 and go up 1 over 1, up 1 over 1, up 1 over 1, but also down 1, left 1, like that. So this is our parent linear function. Okay. Any 8th grader should be able to graph that. Now, if we have y equals x as the parent function, how do we determine the inverse of that? Flip the x and the y. So if we flip the x and the y, we get x equals y. And if we want the y in front, what's going to be my final equation for the inverse? What do you notice? It's the same. This linear function, the inverse of it, is the same as the parent. Okay, so this is the inverse y equals x. So when I graph it, how is it going to look? It's going to be right on top of it, right? The same points. And that should make sense because we all know that they should reflect on the line y equals x. And the line y equals x is right there, right? So if you reflect it on itself, it's going to land in the same spot. Sometimes a parent and its inverse are inverses of each other. Sometimes they are not. Okay. Absolute value of x. What does that look like? It's not exactly the same though. It's V-shaped. So we're gonna go 0, 0, 1, 1, 2, 2, like that. But instead of going down, what happens? Like this, right? Negative 1, 1, negative 2, 2, negative 3, 3, etc. This is the parent absolute value. Okay. So if we flip the x's and the y's, where is this graph going to end up at? Do you agree that this piece right here, if we reflect it, is going to end down here? And this piece right here is going to land on itself. So that's exactly what happens. We have our inverses points over here and over there. Okay. If you reflect this v on the line y equals x, it is a sideways v. Now, I didn't do it algebraically, but if we did it algebraically, if we start with y equals absolute value of x, how do I find the inverse algebraically? Yep. Flip the x's and the y's. I want more people participating, please. So like this, x equals absolute value of y. So the absolute value of y equals x. And we haven't really learned how to get rid of an absolute value. Actually, we did. Didn't I tell you that to get rid of an absolute value, you have to set the inside equal to this and negative this? So you take y and set it equal to positive x. And you take y and set it equal to negative x. So isn't this positive x and negative x? It is. However, we have to restrict the domain for x greater than or equal to 0. I'm not going to explain that why, because we don't need to know that yet. But basically, the absolute value does not go to the left. Okay, it does not go to the left. Okay, let's continue. Square root of x. 0, 0, 1, 1, 4, 2, right? This is the square root of x. So the inverse should be, tell me the points, 0, 0, 1, 1, and instead of 4, 2, 2, 4. Oops, I need to do this in red, sorry. 2, 4. So the inverse looks like this. Okay, the line of symmetry is right here. Very good. Now, if we did this algebraically, y equals the square root of x. We're going to switch the x's and the y's. X equals the square root of y. How do I get rid of the square root of y? Square both sides. So we're going to get x squared equals y. So y equals x squared. Is our red graph x squared? Part of it is, right? Not the whole thing. So we have to say for x greater than or equal to what? If we're only drawing the right side of the parabola. Greater than or equal to 0. So the inverse is y equals x squared for x greater than or equal to 0. Okay, boxing our answers. Okay, almost done. What do we call this one? Rational. And we know rationals have how many asymptotes? 2 asymptotes. A vertical asymptote on the y-axis and a horizontal asymptote on the x-axis. What are some key points? 1, 1, and -1, -1. And that's really the only key point. And the curves follow the asymptote, follow the asymptote, follow the asymptote, follow the asymptote. Okay? So this is our parent rational function. Now we got to find the inverse. So our original is y equals 1 over x. To find the inverse, we have to flip the x and the y. So x equals 1 over y. Ooh, how do I get the y by itself right here? Say that louder. Multiply by what? You have the right idea. To get rid of the fraction, you need to multiply by the denominator. So what you can do is you can multiply this side by y and this side by y. And what's going to end up happening is on the left, you have y times x equals, what happens to the y's on the right side? They cancel out. So equals 1. And then to get rid of the, or to get the y by itself, how do I get rid of times x? Divide by x. Okay. X divided by x cancels out. And you're going to get y equals 1 over x. Again, to get rid of a fraction, you multiply by the denominator on both sides. And then you get your y by it. So what do you notice? It's the same. The inverse of a rational is a rational. So when we draw our curves, they're going to be right on top of each other. Okay, right on top of each other. The line of symmetry is still the same line. And it makes sense, right? Because if you reflect the rationals on the green line, they overlap each other, right? They land on itself. So this is the inverse. Okay. All right, one more. Y equals b to the power of x. What is the name of that function? Exponential. Okay, write it down if you don't remember. This is the exponential function. You learned it in IM1 for the first time. Okay, b is the base. A, which is usually right here in front of b, is the initial value. And b is the base, also known as the multiplier. Okay, so this is the exponential function. All right. So if we start with y equals b to the power of x, and we want to find the inverse, how do we find the inverse? Flip the x and the y. Let's do that. Instead of y, I put x, and instead of x, I put y. So x equals b to the power of y, but we need to get y by itself. Does anybody know how to get y by itself if it's in the exponent? Not the square root. The square root would be if there's a 2 in the exponent. Good idea, though. But it doesn't work here. We don't know. I don't think you guys know how to get rid of y if it's in the exponent, right? How to solve for y if it's in the exponent. So that's what we're going to learn today. How do we get rid of an exponent that's a variable? We know how to get rid of exponents that are numbers, like over here, right? If it's to the third power, we take the cube root. But if it's to the y power, we can't take the cube root or the square root or anything like that. The way we do that is with logarithms. Okay, so for now, we're going to leave it like that. But first, we gotta graph the exponential. So how does the exponential graph look like? There's one key point. It's the point 0, comma 1, because anything to the 0 power is 1. So 0, comma 1, and then it goes like this. Goes up. Okay. So the inverse, we can find the graph of the inverse by just reflecting it on the line y equals x. So if this one had the point 0, comma 1, what is the inverse graph going to have? Instead of 0, 1, it's going to have 1, 0 right here. And we also know that it's going to reflect on the line y equals x. And it's going to follow like that. Okay. So the question is, how do we isolate a variable if it is in the exponent? That's why we couldn't finish this problem. We couldn't get y by itself because we don't know how to isolate a variable if it's in the exponent. Okay, part B. The book is asking, are any parent functions their own inverse? Okay, if you know, write it down. And then part D or C, are any parent functions have inverses that are not functions? Those are the two questions. So we kind of touched on it earlier. Which parent functions are their own inverse? Right, let's go one by one. Is the parabola its own inverse? No, it doesn't land on itself. The cubic? No. The linear? Yes. The absolute value? It does not land on itself completely, right? The square root? The rational? Yeah, the rational lands on itself, remember? Okay, linear and rational land on themselves, and exponential doesn't. So what's the answer to part B? Yes. And which ones? Linear and rational. Any parent functions have inverses that are not functions. So let's take a look at the inverse graphs, the ones that we drew in red. Are any of those not functions? In other words, they do not pass the vertical line test. Let's look at them one by one. The inverse of quadratic, does that pass the vertical line test? No, so that's not a function. This one, the red one, does it passes the vertical line test? This one passes the vertical line test. The absolute value? No. And that's it, right? Everything else passes the vertical line test. So any parent functions have inverses that are not functions? Yes. The quadratic, and what was the other one? And the absolute value. Quadratic and absolute value. Okay. When you're ready, turn the page. Now we're going to do the back side. Number 53. Y equals 3 to the power of x. This is an exponential function, okay? This is an exponential function. And let's see. And what we're going to do is we're going to try and graph the inverse. So do you agree that the inverse of this is going to be x equals 3 to the power of y? Yes or no? If we flip the x and the y? This is the inverse. So this is what we're trying to graph. We're trying to see what this looks like on a graph. Now, over here on the left, I'm going to draw the table for the exponential for y equals 3 to the power of x. And we should know this already, but let's just test it out. Let's pick -2, -1, 0, 1, and 2 for x values. All right. So what happens when I plug in these x values? What do I get for y? Let's plug in an easy one. What's the easiest one to plug in? 0, okay. What's 3 to the 0 power? 1. Another easy one to plug in. 3 to the first power? 3. 3 to the second power? 9. What about 3 to the -1 power? 1/3. 3 to the -1 power is equal to, you make the exponent positive and put it in the bottom and put a 1 on top, okay? 3 to the -1 power is 1/3. So this is 1/3. What do you think 3 to the -2 power is going to be? 1/9. 3 to the -2 power is going to be 1/3 squared, which is 1/9. So that's the exponential, okay? That's what we learned in IM1, and we can just plot those points and graph it. But we don't want exponential right now. We want the inverse. So what do you know about this exponential and this inverse? They are inverses of each other. So what can we do with the x's and the y's? Flip the x and the y values, okay? So do you agree that if x is -2 and y is 1/9, then this x is going to be 1/9, and this y is going to be -2? Is that how we do it? We flip the x's and the y's? Yes. So tell me what to write right here for this x. 1/3. And over here? -1? 1. This one? And this one? 9. Okay, what about for these y's? -2? -1? Very good. So we're flipping the x's and the y's. And that should work because up until now, we know that an inverse is going to flip the x and the y. But why does it work? Let's verify using this inverse equation. X equals 3 to the power of y. Let's plug in for x. Instead of x, I'm going to put 1/9. Is 1/9 equal to 3 to the power of -2? Yes or no? 3 to -2 power is 1/9? Yeah. 1/3 equals to 3 to the -1 power. Is that true? 3 to the -1 power is 1/3. 1 equals 3 to the 0 power. 3 to the 0 power is 1. And 3 equals 3 to the first power. 3 to the first power is 3. And then finally, 9 equals 3 to the second power. Yes, 3 to the second power is 9. All right. And we just have to graph this now. When x is 1/9, is that a small or a big number? That's super small. It's almost 0, right? But it's a little bit to the right of 0. So 1/9, y is -2. So when x is 1/9, so basically almost 0, but a little bit to the right, y is -2. We put a point there. Okay. So when x is 1/3, which is still small, y is -1. When x is 1, y is 0. When x is 3, y is 1. And when x is 9, y is 2. And that's what your graph looks like. Okay. All right. I'm going to write down right here. This is the equation for this graph. Y equals log base 3 of x. Okay. And we're going to talk more about that next. But first, let's ask you these questions. If the input is 81, the output will be blank. Okay, so let's start thinking about it this way. If the input is 81, in other words, if x is 81, what does y have to be so that when you raise, so in other words, to what exponent do I have to raise 3 to get 81? 3 to what power gives you 81? That's what we're trying to figure out, right? Let me say that again. If x is 81, we're trying to figure out the output, y. 3 to what power gives you 81? Say 4, right? 3 to what power gives you 81? The answer is 4. Y equals 4. If y equals 4, then you have 81 equals 3 to the 4th. So 81 equals 81, and it works. So that's the question. To what power do I raise 3 to get 81? That's the question this was asking. To what power do I raise 3 to get 81? And the answer was 4. How can you describe the output for any input x? Okay. So how can we describe this y value? The y value is always going to be the power that we raise 3 to get that number. The power that we raise this number by to get the other number. So it's to what power do I raise the base by to get x? Okay. So have that written down. I know it's kind of weird looking right now, but we're gonna the problems themselves, you're gonna notice that start out pretty easy. Okay. So what I want you guys to do next is on this left margin, I'm gonna turn it sideways because I want to write something right here. Okay. Okay. When you have the log or the logarithm, you have a base, you have your answer, and you have the exponent. Okay. Log base b of x equals y. Log base b of x equal y. Say it with me. Log base b of x equal y. Okay, let's go. Log base b of x equals y. One more time. Log base b of x equals y. If you say it like that, you're going to remember that this is the log, that b, this number is the base. So log base b of x equals y. Notice how b is a little bit smaller and it's on the bottom. X and y are on the same level. Log base b of x equals y. Okay, so this is equivalent to this. B to the power of y equals x. Okay? B to the power of y equals x. They both have a base b. They both have a base, right? They both have a base. They also both have an exponent. I'm going to do this in a different color. They also both have an exponent. And they also both have the answer. Okay, so we're gonna refer back to this to these notes to do these problems. For letter A, what is the base? 2. What is the exponent? The exponent is the number after the equal sign. What's the number after the equal sign? We don't know, right? And then what is the answer? 16. So what part A is asking you to do is it's asking, to what power do I raise 2 by to get 16? That's what it's asking. To what power do I raise the base 2 by to get 16? That's what this is asking. To what power do I raise 2 by to get 16? Log is asking that question every time. To what power do I raise 2 by to get 16? Okay, say it with me. To what power, again, to what power do I raise 2 by to get 16? Again, to what power do I raise 2 by to get 16? Log is asking that question. So when you see the word log, you have to ask yourself, to what power do I raise 2 by to get 16? Let me read the other ones. To what power do I raise 2 by to get 32? Okay, read them with me because it's going to help you a lot. To what power do I raise question mark by to get 100? To what power do I raise 5 by to get question mark? To what power do I raise question mark by to get 81? To what power do I raise 100 by to get 10? And this is your exercise, right? Okay, so let's do part A. To what power do I raise 2 by to get 16? What's the answer? Say it louder. 4. To what power do I raise 2 by to get 16? You said the answer is 4. And that is correct. One way you can do this is you can say, hey, 2 to this power gives you this answer. Okay, so let's write that down. 2 to the power of question mark gives you 16. That makes sense? 2 to this power gives you 16. And what is question mark equal to? 4. Because 2 to the 4th power gives you 16. Okay. Read this for me. To what power do I raise 2 by to get 32? And one way you can do that is you can take the base, and where do I draw my arrow to? All the way to the end. So 2 to the power of question mark equals 32. Let's write that down. 2 to the power of question mark gives me 32. What does question mark have to be? 5. 2 to the power of 5 gives me 32. Right? 2 to the power of 5 gives me 32. Yes. All right. Let's do letter C. Where do I start? So over here, I started with the base. Okay. Always start with the base. Draw the arrow to the end and then come back to the middle. Start with a what? With the base. Draw the arrow where? Draw the arrow to the 2 and then come back to the answer. So how do I write this down? Question mark to the power of 2 equals 100. Question mark to the power of 2 equals 100. So what does question mark have to be? Question mark has to be 10. Because 10 squared equals 100, right? 100 equals 100. I personally, when I first learned logs, I was super confused. But when the teacher drew these little arrows, it helped me so much. So let's continue doing the arrow thing. Where do I start right here for D? 5. Circle the 5. And then the arrow goes to the 3, and it comes back to the question mark. Okay, so how do I write that down? 5 to the power of 3 equals question mark. What is 5 to the 3rd power? 5 times 5 times 5? 125 equals question mark. So that is our answer. Okay. Let's do the next one. What do I circle first? The base. What's the base? Question mark to the power of 4 equals 81. Question mark to the power of 4 equals 81. What number raised to the 4th power gives you 81? Question mark equals 3. Because 3 to the 4th power equals 81. 81 equals 81. All right, let's see if you guys got it. Do letter F on your own. Oh, this one's a little tricky. This is not the same as the exocib, right? It's flipped. The numbers are flipped, but anyways. So this is going to be 100 to the power of question mark equals 10. Uh-oh. This one's a little tricky. It's getting smaller, right? I thought that when you raise something to an exponent, shouldn't it get bigger? Unless the exponent is not just negative. A negative exponent flips it. We don't want to flip it. We just want to make it smaller. Do you agree that the square root of 100 is 10? So what exponent is equivalent to taking the square root? 1/2. Question mark equals 1/2. Because 100 to the 1/2 power equals 10. Did you know that the 1/2 power is the same as taking the square root? So 10 equals 10. Raising something to the 1/2 power is the same as taking the square root. Okay. Raising something to the 1/2 power is the same as taking the square root. Okay. So sorry, that was a little bit tricky. So let's summarize what we learned. We're going to split this box into two. If the original equation is y equals b to the power of x, this is an exponential function. And what is the base? What is the base of this exponential function? Is it y, b, or x? B. B is the base. The base is always a number underneath the exponent. Okay. Now the inverse y equals log base b of x. This is a logarithm with base b. Okay. Exponentials and logarithms are inverses of each other. So this is a logarithm base b. To what power do I raise b by to get x? B to the power of y equals x. Okay. Let's split this box into two. Original f of x equals log base w of x. This is a logarithm. And what is the base of this logarithm? What letter is the base of this logarithm? W. Inverse f of x equals w to the power of x. Is this a logarithm or an exponential? This is an exponential. And what is the base? What is the base of this exponential? W. So the whole point of this is to identify if an equation is exponential or logarithmic and how to find the base. The base of exponentials is right underneath the exponent. The base of logarithms is the little number on the bottom. So if I ask you, find the inverse of y equals 9 to the power of x, remember earlier we couldn't find the inverse when the exponent was a letter? So now we know how to do that. We can turn this into an inverse. Y equals log. Remember, the inverse of exponential is log. What is the base? 9 of x. And that's it. This is the inverse. Isn't that easy? You just have to turn an exponential into an inverse. The only thing you do is, if it's exponential, write the word log, figure out what the base is, and then you're done. Now, if we wanted to prove this algebraically, we could prove this algebraically by doing this. Can't you just flip the x and the y? Y equals 9 to the power of x. So this would be x equals 9 to the power of y. 9 to the power of y equals x. 9 to the power of y equals x. So if we write a log, base 9 to the power of y equals x. 9 to the power of y equals x. Isn't it the same thing? So log base 9 of x is the inverse. Okay, last one. Find the inverse. G of x equals log base happy face of x. So if the original is log, the inverse has to be what kind of function? Earlier we said if the original is exponential, the inverse is log. But if the inverse is log, then the inverse has to be exponential. Okay? So the inverse of g of x is going to be inverse g of x equals, and we're going to have an exponential function. Okay? We're going to have a base and an exponent. What's going to be the base? Happy face. And what's going to be the exponent? X. This would be the inverse. All right. Cool. So I'm going to pause the recording there.